Hey, Grammar 6, this is Mrs. Bunker. It is so nice to be teaching a math lesson, and I am sad that I am not in class with you guys to do that. And especially the lesson we're going to do today is just one of my favorites. It's a really great lesson pulling together some algebra, some great operations. But before we get into that, this is how we're going to be doing class. I'm going to be having some lessons or about 5 minutes explaining all the lesson that you're going to do for the day. Please make sure before you come to this lesson that you have your facts practice just like we do in class, and then you finish your mental math warm-up, including that problem solving. So go ahead then and turn to page 512, which is lesson 96. And today we're going to talk about functions and graphing functions. So function really is just a rule. It's how something works together. So you'll notice up on the middle of page 512, there is a table, and it looks like this. And in the table, S stands for the length of a side. So this right here is side, and then P stands for perimeter. And what this girl tested, Gwen, I guess, yep, Gwen tested and said that for every 5 sides, or for every side, she's going to have a perimeter that is some kind of rule based on the number of sides. Well, if you look at this pattern, is there any relationship between 5 and 20? Well, I know that 5 times 4 is 20. Well, that checks out. Let's see if that is also the same rule that we see in our next term. She has 7 sides, and she has a perimeter of 28. Oh, does 7 times 4, does that equal 28? It does. Let's look at our next. We have 10 sides and the perimeter is 40. Well, does 10 times 4, does that give me a perimeter of 40? It does. So we can deduce then that the rule for this unknown perimeter is 15 times 4. Well, 15 times 4 is going to be 60, so we would put 60 in the box. So the relationship between sides and perimeter is that perimeter is equal to 4 times the side. This right here is the function that defines this table right here. And we could use that. We could even say if there were 100 sides, what would the perimeter be? Well, we could then fill in, I'm going to change my color here. We could fill in, we know that the unknown is my perimeter. We do know that there are 100 sides. Go ahead and do the math and we get a perimeter of 400. So our function is 4 times the number of sides. Let's look at this next table down here. It's the same idea. This is actually example 1 on page 513. And the example says to find the rule for this function, then use the rule to find the value of m when L is 7. So let's just go through and see if there's any relationship between 5 and 20, 10 and 25, 5 and 30. And really, I don't see any. I could say, well, 5 times 4 is 20. So let's see if that applies down here. Does 10 times 4, does that equal 25? No, it doesn't. So we can't use this times 4 as a function. So let's see if there's another way that we could find just the relationship between L and M. Well, I could say, well, 5 plus 15 equals 20. Let's see if that's true down here. 10 plus 15, that does equal 25. Let's try down here. 15 plus 15, does that equal 30? It does. So my rule is this plus 15 that we're going to add to L. So whatever L is, we're just adding 15 to find my output. So let's do it here. We have 7 plus 15 would give me 22 as M. So let's go ahead then and look at example 2. Come down here, you'll see example 2 is find the missing number in this function table. So we have X as my input, and that's another thing. If we were in class, we'd be talking about how X is called input. There's a bunch of vocabulary words to define X. Input, and then you could guess that your output is your function. So whatever goes in X and then applies to a rule, this would be your output. So let's go ahead. So if X is 2, and we have 4. We have 3, x is 3, and then you have 7. There's something happening to the 2 and the 3 and the 4 to give you this output right here. Well, let's go ahead and test if this 2, if we put it here, if it gives us this guy right here. So I'm going to do it over here. Sorry, my handwriting's kind of sloppy on this thing. So let's go ahead and put it in. So 3, yeah, I'll do it here. 3 times 2 minus 2. Well, 3 times 2 is 6. 6 minus 2 is 4. Does that check out there? Yes. I'm going to just go ahead and erase this guy. We're going to do it again. All right, let's try this right here. Let's put 3 where x is. We're going to replace our variable with the value. 3 times 3 is 9. 9 minus 2 is 7. So check, that works out. So if this is the pattern, let's just go ahead and replace my value with 4. Let me get the right pen. All right, there we go. So 3 times 4 is 12 minus 2. 10, or 12 minus 2 is 10. And that's my output. All right, so let's go ahead. And that is not 10. This is supposed to be 10. Goodness gracious. Guys, it's like 9:30 here on Sunday night. Sorry about that. All right, 10 o'clock. It's not 10 o'clock. The answer is 10. All right, moving on. Moving on. Okay, so I'm going to go ahead and turn the page to page 400 or 514. All right, and you'll notice that at the top of page 514, we are now going to take that function table that you see on your left, and we are going to now graph it. So there's this really great relationship between our table of values, our x and our y, our input and output, that we can now take that and also display it as a graph. So what we're going to do is we're going to say, I'm going to grab this. So this is considered my domain, or my x value right here, my independent variable. This is my dependent variable. So on my horizontal axis is my x, and on my vertical axis is my y. And we are going to make sure that we graph this the exact same way, or we look at our sides right here. And I'm going to do it a little differently than what you have in the book, just because I want you to see this table graphed over here. So notice that we're going from 5 to 15. So let's just use a couple hash marks counting by, let's just count by 5s, right? So make sure everything is nice and consistent. And we know that we're going from 20 all the way up to 60. So maybe here we could count by 10s, 10, 20, 30, 40, 50, 60, 70. All right, so let's make sure, sorry, it's not perfect, 10, 15, just so that we're labeling our axes so we know kind of what our increments are. So when our sides are 5 and our perimeter is 20, we're going to go over to 5 and up to 20. When our sides are 7, our perimeter is 28. Well, 7 lies between 5 and 10, about halfway. And we're going to go up almost to the top between 20 and 30. When our sides are 10, our perimeter is 40. So we're going to go to 10. Just kidding about that. Sorry about that. We'll erase that guy because that doesn't count. All right. So when sides are 10, your perimeter is 40. So we're going to go up to 40, 10, 23, 40. Right about there. And then when our sides are 15, our perimeter is 60. So it's about right there. All right, very cool. So you could even then take your line. If I had a ruler, I would be making you guys draw this with a ruler. But notice, straight line, that there's a linear growth here, that as our sides increase, what does our perimeter do? It also increases. All right, so that is a little different than how your graph looks on page 514, but go ahead and take a look at your 500 or your graph on page 514, and it's the same idea, that as your sides increase, your perimeter increases. So let's go down to example 3 then. Actually, you know what? Let's just do it again. You guys can look at example 3. We're going to graph this right here. So I'm going to go ahead and I'm going to draw a graph like this. And you know what? We're going from 5 to 15. So I'm going to put L down here. We're going from, so let's count by 5s again. 5, 10, 15, 20. We're going from 20 to 30. So let's count by, what do you think I say we should do? Fives? 5, 10, 15, 20, 25, 30. All right, so let's go ahead and graph this. When L is 5, what is M? So we're going to, remember this is 5. I feel like we probably should label these since I didn't even know what we had labeled it until I wrote it down. All right, so when L is 5 and the output is 20. When L is 7, the output is 22. When L is 10, the output is 25. And then when L is 15, the output is 30. Again, you're going to see that very clear growth. Sorry, my lines are not very straight. But really go ahead and read example 3 now, and it carries on to the page 514. What I'd love for you to do is to read through that and make sure that you see how it correlates to the graph below. But just this idea, the big idea, if I were to say anything, is that you have your input, you have your output, and there's a relationship when you go ahead and graph it. So hopefully we will be able to see each other somewhat soon and we can go over this in person. But if not, well, definitely not today, go ahead and do your lesson practice now. Make sure you get it checked or you check it in your answer or your solution manual. And we will be having a check-in Zoom class on Thursday. I would love to hear how everybody is doing. So that is that, and hope you guys have a great night. Well, it's probably morning time for you. Have a great day. Bye.